Module 12, Introduction to Third Angle Orthographic Projection. By the end of this module, the student will be able to define third angle orthographic projection, discuss the benefits of using standards when drafting, generate third angle projection views to represent an object. Definition: Orthographic projection. Projection of a single view of an object onto a drawing surface in which the lines of projection are perpendicular to the drawing surface. A brief history of orthographic projection. Orthographic projection was called analemma by the Greeks. The current name was adopted in 1613 by Francis de Ouglion of Antwerp, Belgium, though it is thought to originate from the Roman writer and architect Vitruvius. Orthographic projection was formalized by Gaspard Monge in 1746. Monge worked as a drafter at the Mézières School for French Army Officers. His work was kept a military secret for a number of years, until he was allowed to publish his work in 1795. Stonecutters were the first to adopt his standardized methods. Later, carpenters and other trades abandoned their old drawing methods for the orthographic projection standard. Let's talk about standards. Why do we have standards? Why is it important for us to produce drawings using a standard? Think about these questions in the context of a global village. Because we use drafting standards, we can communicate with people and companies from around the world, and often with people who don't speak our own language, or are even on different time zones. Think of our own country, Canada. We have 2 official languages, as well as countless other unofficial languages. If we are in Ontario, for example, and find a company in Quebec who can manufacture our part either better, cheaper, or faster than anywhere locally, with proper drafting techniques, we can eliminate the need to translate from one language to the next. All important information can be easily read from our standard drawing. It is easy to see that by being able to communicate with the global community, we can have our products manufactured anywhere in the world. Many large multinational companies such as General Motors will utilize employees from a number of their offices located throughout the world. Even with language, time zones, and cultural barriers, they are able to communicate easily with standard drawings. By adhering to drafting standards, we enable our drawings to be easily understood by the greatest number of people. If a reader of one of your drawings has a question, by using standard drafting, it could be answered by anyone who has been trained to read blueprints, or they could reference any decent drafting book. If you prepare your drawings correctly, you can eliminate many, if not all, the questions that can delay, increase cost, and delay production of a project. Think of the number of parts in a car. There are literally hundreds of thousands. Think of the number of people required to make that many parts. Again, hundreds of thousands. We can see how important it is to follow drafting standards in order to communicate with this many people. There simply would not be enough time to speak with each individual involved with a project of this scale. The North American standard for orthographic projection is third angle projection. Europe and Asia use a similar but slightly different projection method, that of first angle projection. We need only be aware of this at this time, as we will solely and only concentrate on the North American standard third angle projection. All drawings produced in North America, regardless of what industry, are done so and are assumed to be drawn in third angle orthographic projection. What is orthographic projection? Orthographic projection is the projection of object features onto an imaginary plane called a projection plane. This imaginary projection plane is placed parallel to the object. Thus, the line of sight is perpendicular to the object. This results in views that appear two-dimensional. How many views will be needed to completely show an object? This will depend on the object itself. There are 6 two-dimensional views that will completely show all sides of a rectangular or square object. These 6 views are the front, right side, left side, top, bottom, and rear. The views are placed in a standard arrangement so others can read the drawing easily. The front view is the central or most important view. Other views are placed around it. 6 views are not always necessary. Actually, there are very few products that require all 6 views. The number of views needed depends on the complexity of the object. Use only enough views to completely describe the object. Drawing too many views is time-consuming, confusing, and can clutter the drawing. In some cases, a single view may be enough to describe the object. The number of views required depends entirely on the amount of views it takes to completely describe the width, height, depth, and features of the object. Selecting the front view. The front view is usually the most important view. The following guidelines should be considered when selecting the front view. Look for the best shape or most contours. Show the most natural position of use. Display the most stable position. Provide the longest dimension. Contain the least amount of hidden features. Additional views are selected relative to the front view. Choose only the number of views needed to completely describe the object's features. The glass box. The glass box is probably the most common and best way to learn, understand, and visualize third-angle orthographic projection. Imagine that the object you are going to draw is positioned inside of a glass box, so that the large flat surfaces of the object are parallel to the walls of the box. From each point on the object, imagine a ray or projector perpendicular to the wall of that box, forming the view of that object on the wall or projection plane. If we do this for all 6 sides of the object, we will have every view to represent that object. Imagine that the walls of this box are hinged and are able to unfold the views outward around the front view. This will give you the standard arrangement of views for third-angle projection. This hinged glass box method can be used to represent any object. By using this hinged glass box method, the result will always be the same, a correct third-angle orthographic projection drawing. Now that you have completed viewing the module video, approach your instructor and ask for the Module 12 exercise and workbook. There are numerous examples, along with definitions, exercises, and a multiple-choice unit quiz. When you have completed the workbook, return all resources to your instructor and ask for further instructions.